Okay, so on Tuesday I showed you how to install Sedanal, and I took you through um, setting up a model and then also doing a simulation. So what I'd like to do now is sort of go through this simulation process again with you and then show you how we can use it to analyze some of those data that we simulate. So I've opened up the program and I'm going to hit the preprocessor button, and it will open up a fit screen. If you've already gotten it to work, here under last will be some examples of data that we've already fit. So I think we fit something that might have had 2 micromolar in it. And so that's one thing we could do. We could just pull in your last fit. For those of you who haven't actually fit data yet or simulated data yet, maybe what we should do is actually do new. So just click the new button, click sim, click OK, and then under this new control file, you see it's going to repaint the screen as though there's nothing there. And I'm going to type in sim tubulin a model, and I'm going to do something like 1 micromolar. Okay, so I'm going to do mu 1 micromolar. Okay, so this is just a name of what we call an ABC file that allows you to repaint the screen in exactly the same way. And then here we've only generated 1 model, so you should only have A there. You're going to type 1500 for numbers of points. You're going to type 100,000 for the molecular weight of tubulin, 5.8 for its S value, 0.27 for a buoyancy term, and a 1.44 for the extinction coefficient. And then we're going to click Simulate. And then down below we're going to do absorbance. In this description window, tubulin at, I think we just said 1 micromolar. You want to put 5.9 in the meniscus. Experimentally, that's what it is, 7.2 at the base. We're going to do 30,000. Okay, over here, click on the red and bring this to moles per liter. If you click, make that go away. There we go. If you click back and forth, you can go moles or grams per liter. Let's just do 1 e to the minus 6. Okay, we're going to add noise to this. Let's do 003 for this sample. There's 1,500 points in the simulation, but we want to output 650. That corresponds to the density at which we collect points, 0.002 centimeters between these differences. Okay, and over here it's guessing 348. I'm going to increase that to 400 because I already know that's not quite enough. Okay, so we're going to do 400 scans. We're going to simulate an A model, 100,000, 5.8, 0.27 density and current 1.44. Under advanced, under simulate, we want to output an ABR file. We don't need to output these ABC files. So let's just output this ABR file. Okay. And then we're ready to go here. So we're doing simulation, 1 micromolar tubulin, 5.9 to 7.2, 30,000 molecular weight, 1 e to the minus 6, 650 points. We're putting some noise on it. Come up here to the upper right, click store and save, and it will start simulating. Notice the plateau is at about 0.14. So that's about 10% of, 1/10 of, the maximum extinction for 1 mg per mil. Okay, when it finishes, the blue box opens up, you hit close. It's going to come back over here, and I'm going to hit last again just to show you what we simulated. Okay, so it recovers that screen. So we've now simulated data. I've actually already simulated data at 2 micromolar. And so what that does is I've named it 2 micromolar in the ABC. I've named it 2 micromolar down here in the concentration. I've named it 2 micromolar in the description. And then I also already did 4 micromolar, 4 here, 4 micromolar, 4 micromolar, and I've already done 8 micromolar. Okay, so we actually have 4 data sets out there now because we just did 1 micromolar. Okay, so let's cancel out of here and go over to preprocessor. Click on this upper box and choose your simulation subdirectory. And then under this cell type, you may only have 1 micromolar data right now. Okay, so click on it. And notice that I've drifted out of the the viewing box. I'm going to drag me back into the viewing box. So let me say that again. You're going to click up here at the top and you're going to choose Sim. And then underneath the cell type, you're going to choose your 1 micromolar data set. And what I'm going to want you to do is go and simulate the 2 and the 4 and the 8 micromolar. Okay, and so up here under Select Scans, it randomly chooses scans to show you examples. What I want you to do is choose something like 60 over here in this box, and then down here in the bottom put something like 200, and then say OK. And it will have every scan between 60 and 200, and then I'm going to change the scale here by putting in something like 0.2, and there's the data. You can see that it's chosen a range over which to fit the data. This is a little too deep here. I want to click on range, and then when I drag the cursor over here, I'm going to click down but hold and drag it to about here. Okay, it's already put the meniscus at 5.9. It's already put the base at 7.2, so it knew that in the simulation. Okay, so I'm going to choose a set of data that we can analyze. Then I'm going to say write. Now, if you simulate the 2 and the 4 and the 8 micromolar, you have to do the same thing. So I've already done that, but let me show you. If I go to the 8 micromolar, it's already selected scans. It's already showing you where the meniscus, the base you can't see because it's just off to the right, but it's 7.2 down here, and then I've adjusted the range in here. Okay, so let's say OK. Let's go back to the fit window. And it's going to paint the screen again. So what we want to do now is fit those data. Okay, and so I'm going to again say new, go back to sim, and I'm going to do fit sim tubulin A model, and I'm going to just say 1 micromolar. Okay, I'm just going to choose 1 micromolar data set. Here under A, I'm going to pull in the A model. So now I'm going to actually fit real data. I'm going to still put 1500 here in the simulation of the data when we're fitting it. And now I'm going to put in these same numbers, 100,000, 5.8, 0.27, 1.44. And now down here under data, I can choose a data set to enter. So I'm going to choose to enter 1 micromolar. And over here, I'm going to click the blue box. So this is 1 e to the minus 6. Alternatively, it could be 0.1 grams per liter. Okay, and then over here, I'm going to right-click on the data and select the scans to fit. Right now, it's selecting all the scans. I want you to come over here to this lower right corner and click Copy. And it will do 60 to 200. Okay, so now we're going to fit the data that we simulated. And then the other thing is, right now we're fitting the concentration, but we're not fitting any of these parameters because they're all blue. If you right-click on the 5.8, we'll now fit the S value. Okay? So, we've given the fit a name, the ABC file a name. We're using Analyze. The A model, 1,500 points across the cell. We've chosen a data set. And so now we're going to come up here to the right and actually try doing a fit. And what it's going to do is it's going to show you these difference curves. And then down below you can see that it's fitting to the S value and the concentration. It's giving something that's real close to the right answer because this is perfect data. And then it closed, it finished. The fit came back out at 4.25 10 to the minus 3. Remember, we actually added 3 micromolar when we simulated this. Okay, 3 micromolar simulated. When you take these difference curves, okay, you add some amount of noise. And the amount of noise is the square root of 2, and the square root of 2 times 3 is 4.25. So the noise here is 4.25, 10 to the minus 3. And this is the goodness of the fit. Okay, so let's close this. And let's do one more thing, and then I'll stop and go back and do something more complicated in a different recording. So I'm going to do last. Notice when it pulls it back in, it has 5.8 and 1 e to the minus 6. If I click B up here, it will show you what the fitted values are. So you can see it's close to the initial guesses. Okay. So now up under here, under Advanced, I want you to click, and I want you to do something called Calculate an Fstat. And I want you to calculate a 95% confidence interval, so that's 0.95. That's actually 2 standard deviations. And I want it to be, let's click on here under Johnson and Strom, equation 35. It's the way it's going to estimate the error. I'm going to say OK. Come up here to 5.8, and when I click on it, it's going to show you the Fstat option. So I'm going to calculate an Fstat on the S value. And then click on the concentration as well. I don't usually do this for concentration, but we're going to look at it. Okay, so what we're going to do is we're going to do an Fstat. So I'm going to change the name in the ABC file to say Fstat. And then I'm going to come back over here and I'm going to repeat the fit. But then at the end of the fit, it's going to do statistics. And so here we go. And so watch what happens. It will do a fit, and then it will flip to an Fstat. And I'm actually going to click on another box that will bring up the parameters it's doing the Fstat on, so you could see that as it does it. And it's actually going to plot points. Can you see these points appearing here? 4, 5, 6. What it's doing is it's looking for a point that's close to this line. This is the Fstat line. And when it hits a point, there's 9, and I think it's going to stop. It hit 10, and it stopped. And so it told me that the value is this value of 0.99, and then it's going to do the other side. So it's making a parabola, the error to the bottom and the error to the top. And as these points get close to the line, it's going to show you where the error is. And then it's going to stop when it hits that best guess. And so it says that on the upper side, the error is 1.0015. That's pretty tight. And now it's going to do the same thing for the S value. On the left, you can see it's doing iterations. It's sort of stepping through values, and it's trying to get to an error place. And when it hits the value, 5.79, it's the lower error limit. And then it's going to do the same on the top. And so you can see the points are bouncing 14, 15, 16, 17, 18. It's probably going to do another one, 19, and then it's going to stop. So it shows you the error limit on the S value and the error limit on the concentration. So when we talk, I'll show you what this means in a little more mathematical terms. Okay, so we've done a fit again, and we've done some statistics. And so let's say close. And it's going to, if I double-clicked last, it would bring back that best fit. All of this information is stored in an output file. It's actually a Word file, which we'll talk about next time. So I'm going to stop right there. We're approaching 15 minutes, so I'm going to stop right there.